Okay, so we're back on, and we want to write a C program which uses a struct variable in order to to save some basic information about, not save, but display, right? Display some basic information about students from a file. Once the information has been read from the file, we will display all the information from the struct on the screen. So the information is going to be stored inside of a file, right? And we could probably use the same student info file that we had here. I'm going to put some more students' information inside here, right? We have Ryan and Louis. Ryan, I've given you a birthday of the 27th of the 2nd, 2004. Right? Let me put Jaden inside here. Jaden. Right, so Jaden, your information is inside here too. Jaden, I feel, right? Oh, sorry, comma, right? So, okay. So Jaden, you are the 3rd of the 8th, right? 2004. Right, and let's put in one more name. Let's put in Chelsea Clark. Right, Chelsea Clark, and Chelsea, you are the 6th of the 9th, 2004. Okay, so the 16th to the 9th, 2004. So we have 4 names inside of our struct, and we want to read all of this information, right? So we have names inside of here. We want to read the information from the struct, from the file into the struct. But the struct is not just going to be a regular struct, it's going to be a struct array. All right, because we're going to read all 4 of these names in it at the same time from the file. So we have the information from the file. We're going to use the same struct that we had from before. Here I'm just taking out the form class and the ID information because we're not using that from the file. But if we have to declare a student, and I'm going to show you something different. Let's say, for instance, you notice that when we declared down here, we said struct student, right? Yeah. When we said struct student, right, this was us declaring the data type. There's an alternate way that will save us one word. I'm just showing you all it just for the fact that we could see it. We could say type define, right? Struct, and instead of putting student here, we put S here, and then you can put student down here. All right? We put student down here. And then what we do is that we could just simply say student, right, stu underscore list. What did I do there? I redefined struct s to be student. So instead of having to put struct student, all I need to do is put the word student. So basically what I'm saying is struct s, which would have been struct student, I am redefining that to be student. So down here, all I need to do is put student. Let me just make sure I did that correctly. All right. Okay. All right. All right. Type def, not right. So I redefined struct s to be student. So the data type is now student, and we don't have to put struct student. That's all that it is, right? If this confuses you, you could just do it like this format here. Okay. So we have student listing. We have the student listing, and this is now an array. So we've created an array of type student. We can hold information on 10 students. Basically, what I've done is before, if we thought about a student holding this information here, right? What I did when I said student, right, stu underscore list 10 is that I have created 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've created where I can hold information, right? Like, of course, the name, right? The day, month, year, right? F name, etc. And I could do this 10 times. Raise your hand if you're with me. I ain't seeing no hand raised. All right. Okay. I have people with me. Good. Good. So I see some people that raise the hand yet. Okay. All right. So I have some people with me. All right. And so we have this, we have our structure, we have our information inside of our file. How do we put it inside of here? How do I get this information into this structure? Well, the first things first is that I have to read the information from the file, right? So for me to be able to read the information from the file, I have to have a file pointer. I have a file pointer, right? And I could start off by opening the file to read. So I could say fp is equal to fopen, right? What's the location of my file? C:\\, folders underscore C, \, and student underscore info.txt. Right, and I open the file so that I can read from it. So open the file to read from it. And what do we have to do every time we open a file to read from it? We have to test that file. We have to test that file. So we'll say if fp is equal to null, right? We could say printf, right? File read error. Put a get char here to pause screen output, and put a exit 0 to exit the program. Okay? So if our file didn't exist, then our program would quit. We could run it. Our file exists because the program stopped and we didn't have any error messages or anything. So, all right. So you can put return 0 here, right? So now we know that the file, we can read the file. How do I know, how can I get all of my information from my file. What do I have to do? Typically, when I read information from my file, I use a line of text or a string that will read a line of text from my file. And you will start to see things that we did before coming together to start to make sense, right? As something that we could do to, to build a bigger system. So it's all the little things that we have been doing that now come together to be able to make it so that we could do this one big thing in terms of getting our program to work, right? So a string that will read a line of text from my file, and of course I will say while, right, in equal to file under file for FP. What do we want to do? We want to fgets. What do we want to fgets? We want to fgets line, comma, right, 100, comma, from FP. So this is to read a line of text from the file while we are not at the end of the file. Okay? While we're not at the end of the file, read a line of text from the file. And what do we want to do in terms of reading the line after we read the line of text from the file? Let's just print it out. But this is, we remember the goal here. The goal here is not to just print it out as it exists in the file, but we want to store it in the struct. We want to store it in this struct student list. Right? We want to store it in this struct student list. So, but for testing purposes right now, let's just make sure that everything is getting read. So we could just simply printf %, $D, sorry, not %, $S, right? And I print out the line from the text. Okay? And yes, everything that's in the file is coming out. But you notice the date of birth, as it is in the file, we have commas between the names and everything, and we usually use a slash between our date of birth. So when we're printing it out from the struct, we could format it in a different way, right? So printf %S line, we know that it's coming out, but this is not how we want it, right? So this was just a test line to make sure the data was read from the file. So what do we want to do now? Well, I know that I have my first line read. So I had my first line read with Eden here, but I need to break this line up to be able to put that information inside of my struct position. And we know that an array starts at position 0. So we could say int I is equal to 0. Right? So this is the index for my struct array. So we want to put the first line of text in the first position in the student list struct. Okay? So we already have the information inside of line. If I want to put information inside of I want to put information inside of the first name, what can I use to split the first name away from the rest of this line of text? Anybody could tell me what I could use to split that up? Let me give you a hint. It's in the string.h library. Anybody could tell me what to use? We did it a couple classes ago. All right? I could use a string tokenizer. So I could say token is equal to strtok, and I want to break up line. I want to break up line according to the commas. So my token right now, my first token will be the first name, right? So I will get the first name from the line by tokenization, right? According to the comma character. So I'm tokenizing it according to the comma character, right? And let me put this let me put this in double quotes so that because that is supposed to be a string, right? So we get the first name from the line by tokenization according to the comma character. And if it is that I only wanted to print out first names, again, I could test by saying printf %s, comma, token. And this here should run me through all of the first names, putting them into token, and I could print them out. But remember, the goal is to put it inside of the student list structure, right? But this is just for testing purposes only. Look, I get everybody's first name, right? Hey, Jaden, I spelled your name incorrectly. Did I? Right?
Yeah,
Jaden.
yes, J-A.
Yeah, yes. Sorry about that. All right, so we have everybody's first name. So why not now take that first name that is stored inside a token and copy the first name to the current index of the copy the first name to the current index of the student underscore list array. Okay, how do I do that? I say strcpy, right? Our destination always goes first. So what is our destination? Our destination is stu underscore list at position I dot, and what do we want to put inside of there? We want to put it in the f underscore name, right? stu list underscore I dot f underscore name. So now I copied the name that I just took and put into the token inside of there. And I could continue doing this for token is equal to strtok. If I want to continue tokenization, I put null here and I continue in tokenizing by the comma, right? So get the last name from the line of text read, and we want to store it in, right? We want to store it in the struct for the last name, right? Store it in the struct for the last name. And then what we want to do, we want to get the birth date. So the birth date has to be the same thing. But the birth date, if you put the birth date into a token, right? So token is equal to the same thing as here, right? This will be now to get the birthday date of birth day value. To get the birthday value, right? And what do we want to do with getting the date of birthday value? We want to put that into the position here, but this is an integer and the token is a character. So we'll have to convert it, right? But luckily converting that is easy. So we could go stu underscore list at position I dot birth underscore day is equal to what? There's a special function called a to I that will allow me to convert this character token as long as it is, so in this case it's 14 that would be passed here. 14 will be converted from, it will be converted from 14 being, right? Let me illustrate it for you. Because the token is going to hold 14, I am converting it to, right, this is stu underscore list at position I dot birth underscore day, right? It will convert it to 14. Now, because we know data types, we know that this here is not the same as this here. This is an integer, and this is a string, right? Which is also a character array. Are you all with me? Are you with me? You all understand what we're doing?
Yes, sir.
Right. So let me just clear my screen. Right, we're clearing the screen and we're going back. And so we converted, right? Convert the token to an integer using a to I, right, function and store it in a struct array. And so we can do the same thing for the other two areas, right? We say token is equal to, right, the same thing here basically. Token is equal to that. So now we get the next token, which should be 7. And then we'll see, right, stu underscore list at position I. Don't forget that because now it's an array, right, we have the array index on the struct variable name, right? We get birth month as the element is equal to a to I for token. Okay, so we convert and store the month, and we do the same thing for the year, right? Birth underscore year is equal to a to I for token, right? Convert the year. So at this point, we have everything that was inside of the file now stored in the struct array, this student list. So if I were to go down here and say for, and let me use a different variable now, right? For j, is equal to 0, semicolon, j is less than I, semicolon, j plus plus. Hold 1 second, please. Yeah. Is that your? No, that's not. Okay. All right. Okay. Yeah, sorry about that. Okay. We want to now print it out from the struct. All right. We are printing out from the struct. So what we're doing is that we read this file, we place the information in the struct. All right. So we say for as many records that was read from the file, right? And in this case, that should be about 4. Okay. And I forgot to put I++ up here because, of course, every time, right, increment I to put the next line in a new position in the array. Okay? So for as many records that was read from the file, which is indicated by the final value of I, we now want to print out printf, right? We could print out %s, space %s, right? Let's put colon, %d slash %d slash %d. And now we can say student underscore list at position j dot, right, first name, right, that, last name, birthday, comma, birth month, comma, birth year. And we could print out everybody's information, right? Print out each person's information formatted as we would what. Okay? So let's see. Oh, sorry, I forgot to string copy the token into the, string copy. So that's right, we taking the token and we copying it into the structure. So let's see, it comes out exactly as we wanted it, with slashes in between the dates and the spaces in between the name. Whereas in the file, it was recorded as commas. So really and truly, we processed this data, right? We have just processed this data. This data was in the file. Now, if I add another person inside of here, right? Let's add Chanel, comma, Edwards, right, comma, the 30th of the 11th, 2004. All right? Chanel Edwards gets added to our. But it's important that the format is adhered to, because the format is what the computer is expecting to be able to reformat it into however we want to display it. Right? Because look, the slashes here were based upon what we said to put in. Right? %s and %s here. And that's what, that's what we get in here. So any questions on what I did here? Any questions?
So, but you always had to write up the text file beforehand.
No. We could have used this same code with a little modification. We could write this text file using this code here, Because
Okay.
remember we just wrote one line, right? We
Yeah.
just wrote one line to the text file, but in reality, we should write multiple lines to the text file.
Okay.
All right. So
But
yeah,
it's
it's,
just,
it's all it's all about taking the stuff that you know and putting it all together.
okay.
Yeah. Joshua?
Yes, so you could explain only general thing what you're doing because I wasn't getting to see any of this. So.
All right. Basically, what we were doing was that we introduced the concept of a struct. We introduced the concept of a struct being a variable that contains other variables that are all related to each other under a common name, right? What we started off by doing was that we started off by putting data into a struct and writing the data from the struct to a file. That was the first example that we did. So we had the student structure, and what we said is that once you declare a variable of type student, you are able to access any of the members that are now inside of that struct that was defined. So we put in the student's first name and last name into the stu variable, and we put in their date of birth as well, and then we wrote that information to a file. Then we said, if, say for instance, we had a lot of information inside of a file about students, right? We had a lot of information inside of a file about students. We had various students on different lines of a file. We could actually read the information from the file into a struct array, right? Which was student list in this instance. And then we could display it by reformatting it as we want. So basically we're breaking up text from a file into different members, so that each part of the struct, each item of data inside of the struct is granular. So we can essentially just display it as we want, and not initially as we printed it out, which would have been limited to the format expressed in the file. Now this is also important because let's say for instance I had 2 students who were born in 2005, right? And I ran this. What if my program had something in it that said, okay, I could sift student by year of birth. I could now run through and look at this element of my students contained inside of the student list and say, okay, just show me alone all students who were born in the year 2005. You understand now how we can, it's all part of being able to manipulate data. Are you all with me?
Yes, so you're using the data from the file itself, or like you're grouping it from the program.
Yes, so you're essentially you're loading this data from storage, which is the file, into memory. Once the data is inside of an appropriate memory structure, you could manipulate this data however you want. Understood?
All right, so
All right. All right. All right. So I'm going to pause the recording from here because I'm not showing anything new again for the class, and then I'm going to probably give us a little exercise to try and do now, okay?